This problem says a solid cylinder rolls up an incline at an angle of 20 degrees. If it starts at the bottom with a speed of 10 meters, how far up the incline does it travel? Okay. So this is a cylinder, and when they tell you that, what they're telling you is they're essentially telling you what its moment of inertia is. Okay. And so it's still a cylinder when it goes up there. It's rolling up. It's going, initial velocity is 10 meters per second. Okay, so what we're finding is how far up the incline does it travel. So we're finding this distance. Okay. Yes, today is not a good day for recording. All right, so what is happening is, what we're trying to find is how far up the incline will it roll. What happens is the kinetic energy at the bottom has gotten converted to potential energy. Okay, so that's the principle we'll use. Energy at the initial point is equal to energy at the final point. Okay, so only conservative forces were doing work. Only gravity was doing work. Okay, so at the bottom you have translational kinetic energy plus rotational kinetic energy. Okay, and that is equal to mgh. It's the height that this thing has risen. See, the center of mass has risen from here to there, and it has risen that height. Okay, so this kinetic energy got converted to potential energy. Okay, now the linear velocity is related to angular velocity like this. So what we are going to do is 1/2 mvi square plus the moment of inertia of a cylinder is 1/2 mr square, and omega I is vi by r square, and so this is equal to 1/2 mvi square, and the r cancels, r square cancels, plus 1/2. Oh, this was, I'm sorry, so this was 1/2 of, there's the moment of inertia. I forgot this half. There's that half, and there's the moment of inertia. Okay, so this is 1/4 mvi square. All right, what this is saying is, so this is the translational kinetic energy, and this is the rotational kinetic energy. And you see the rotational kinetic energy is 1/2 of the translational kinetic energy. Okay, so if it has $100 in translational kinetic energy, it has $50 in rotational energy. That's what that is saying. And that's equal to 3/4 mvi square, and that should show up as mgh. The mass canceled. What does that mean? That's right. every mass, no matter how heavy it is, the same dimension, same velocity will end up at the same height. Okay. All right. So H is all right. So this works out too. So H works out to 7.65 meters. Okay. And what we are really finding is what was that? The incline was 20 degrees. H, that D is what we're trying to find. So sine 20 is H by D. All right. So again, that's quite a distance. 22 meters is roughly the width of this room. So imagine a 20-degree incline. It would be actually, so in the speedway, the turn has 30-degree inclines. So essentially, this is a cylinder that would roll up that incline. Okay. And just to give you guys a sense, 10 meters per second is 25 miles an hour. So you roll a cylinder at 25 miles an hour and it'll go. Okay, guys, so I believe that does that problem. Yep.